Hello, welcome back. I have become tiny again because I am going to do some drawing on this piece of paper, and I would like you to take notes as well. I think that taking notes in handwriting is a great idea, specifically in this case because the things I'm going to be drawing are some symbols. What symbols are we going to be learning? Schematic symbols. These are symbols that are used all over the place to communicate the structure and interconnections of electrical circuits. By starting with the symbols, we'll have a common symbolic, semiotic ground from which to show circuits to each other. You can think of it as in the good old days, let's say you had written a piece of piano music and you wanted to transmit how to play that song to your friend in Australia, but you couldn't send them a recording because this was pre-recording. So there is a way to do it, which would be some like really complicated way where you could draw a graph of like every single key on the piano and like say this is when you should press this key or something like that. But a much more efficient way to do it is say, well, we're going to come up with a notation system. As long as we agree on the notation system, I can send you some sheet music and you can play my song, friend in Australia. Similarly, we are going to be learning about a common notation system used all over the world by people who are wishing to communicate electrical circuits to each other. So these are very good symbols to be familiar with so that you can read lots of schematics. I will start with a little caveat. Yes, there are differences between American and the rest of the world symbols. I will show you some of those differences, but for the most part, we're just going to focus on the American symbols, and please know that you won't have to learn a whole new language or something to be able to read, for instance, Asian and European schematics. They won't be wildly different than what you're used to if you understand this system. So, symbols. The very most basic and the simplest thing that you'll ever need to draw is a connection between things, which is just a line. And this is the symbol for a wire. It's also called a trace. And all that means is a connection between two things. Now, I will pause already and note that if I draw a wire, I draw this little straight line. That does not indicate if that's a very long wire, a very short wire, a very thick wire, a very skinny wire. It doesn't tell you anything about it. All it says is the thing on the left is connected to the thing on the right. The schematic frequently omits those details. It focuses on the topological qualities of a circuit rather than worrying about details of wires and lengths and sizes and shapes. Sometimes you'll have two wires connected to each other. There are different ways to represent this, but the system that I like draws a dot at the place they connect, and that dot is called a node. A node, N-O-D-E, is two or more connected wires. Sometimes you have wires in your schematic that might need to cross paths, but you want to indicate very clearly, no, they're not connected. They are merely crossing paths without being connected. So if I draw one wire over here and then I draw another one like that, those are crossing wires, not connected. Now, a very basic component, and one of those which we're going to learn pretty early on, has a drawing that looks something like that. You could see from the drawing, it gives you a clue. Frequently, the schematic drawings give you a hint as to the purpose of these things. So in this case, it's something that's kind of a little door. It can be closed or opened. That little door is a switch. Now, there are many types of switches. To begin with, we're just going to say, that's a switch. It can either be like this or like this. When it is like this, when it is closed, so I've drawn it here in what's called the open position. When it's in the closed position, power can go all the way from here through the what would be the closed part. I drew a little dotted line to indicate that, to the other side. When it's in the open position, power cannot get across because there's a gap. And we are to understand that if there's a gap, power is not able to flow. Another very important symbol is drawn as kind of a zigzag in the wire. This is a resistor, and exactly what a resistor does, we're going to need to talk about in a bit more detail later when we talk about actually how to design circuits, but for our purposes, let's just say that's how they're drawn schematically. Here's another symbol that is in its symbology, in the choice of symbols that they used when coming up with these symbols. You can actually get a big clue as to what it is or how it works. This is basically a one-way gate for electricity, and I want you to look at it. Consider that electricity might be flowing left to right, it might be flowing right to left, and which way do you think this one-way gate would allow it to flow? In this case, it would allow it to flow left to right, following the kind of arrow that's built inside of it. And I think of this thing over here as a little brick wall. So if the electricity tries to flow this way, it will slam into the little brick wall. It will not be allowed through. The name of the circuit element is a diode. Now, sometimes you will see another circuit element, which is also a diode, but it's a special kind of diode. I'm going to start by drawing a diode, then I'm going to draw a circle around it, and then I'm going to draw two ziggy-zaggy lines coming out of it. This is a special type of diode. This is a light emitting diode, which is typically abbreviated LED. We've already seen some LEDs on the Arduino board, the power light, the TX and the RX lights, and that little light that we made blink that's attached to pin 13. Those are all LEDs. In a schematic, they would look a lot like this. Next up, let's say you are drawing a schematic and you have something over here which is connected to something over here, but you do not wish to show, you don't want to draw the wire between them. You just want to say like, yes, this is connected to that. There is a way to do that. There's a way to sort of save the trouble of connecting every single thing that needs to be connected to every other single thing with wires. And the way we can do that is by drawing a net, or we could call it a named node. And this starts to get a little bit fuzzy or complicated. And the styles are also a little fuzzy or complicated. But so for the time being, I will say, let's say sensor. I could draw it different ways, but I'll do it like this. That little place with a sensor is also connected to any other place that I draw that same little thing. I would say, okay, well, any place, like though there is no wire there, actually those things are connected. So this would be useful if you have something way over on the left of your schematic, you want to connect it to way over something on the right, or 10 different things in the schematic, all of which need to connect to each other. I don't want to bother with drawing all those wires. It would be a mess. So I can use a named net. Net, as in a bunch of things that are connected to each other, like a web, or a named node. The nomenclature around this does vary a bit. Now there's a special kind of net where there's a lot of things we're going to frequently connect to each other. I'm going to write the words 5V, and we should understand V in the electrical context means volts. So 5 volts, I'm going to draw an underline and put a little whisker coming out of the bottom. That means a connection to something that's called 5V. You could think of it if I also, instead of the word sensor in here, if I drawn 5V, that would be the equivalent. So this is a 5 volt net. Anything that connects to this, it's a lot like this, it's just a different style essentially, is connected to 5V. Where have you seen it? Well, on the Arduino, one of the pins was labeled 5V. And that is essentially power as far as we're concerned. At least at the beginning, that is kind of equivalent to power. So we're going to be using that a lot. There's another thing that we're going to be using a lot that's essentially another named net. This one just has another special symbol. That thing is going to look like that. This is called ground, and that is the same thing as 0 volts, V-O-L-T-S. Exactly what is meant by volt and what is meant by ground, we're going to talk about that when we think about sort of electrical theory more broadly. But for the time being, understand also that if you were to basically write the word ground in this bubble and write the word ground in this bubble, any two things in the circuit that have that symbol, they are connected to each other. And they're connected to this thing called ground. Finally, one little symbol that is useful, and I'm drawing it here sideways, but these symbols can be rotated 90 degrees or 180, or you can write them at 45-degree angles, so that's less common. And I'm going to add a little annotation here just for clarity. I put a little plus on the left, a little minus on the right. This is a battery. And you're familiar with batteries. There are big batteries that make like electric vehicles go. There are small batteries that power your watch, etc. All of those could be represented by a symbol just like this, battery. And I just want to show you what some of these symbols look like on a computer. Some of them will be kind of the same, but some of them might vary a bit. So I'll shift this over to the right, and I've got loaded up here some different symbols in a piece of software. It's not a piece of software, really. It's a website. It's called Circuit Lab. And if you're a student at Carnegie Mellon, you have access to Circuit Lab. You can go to circuitlab.com and you can sign in with your Andrew credentials. If you're not a student at Carnegie Mellon, you might have access through another institution, or they have a paid model. You can pay them some dollars. If you want to use the free version, I think they prevent you from like saving the circuits or something like that. And it's actually a very useful piece of software. It allows you to simulate circuits and do all sorts of things. But I just want to show you in this moment what the symbols look like there. So wire or trace, that looks pretty much the same as we've seen. There's a node. So we see those two wires are connected with a little dot. It could be a pretty subtle little dot, but it's there. Two wires crossing but not connected. That's just like we've seen. Notice that the little hop could go horizontally or vertically. Doesn't really matter. A switch, and as noted, that switch is open in the drawing there. A resistor, that's pretty much the same. A diode, so they have filled their diode in. I left mine open, doesn't matter. Aha, here's a difference. The way they represent a light emitting diode is they still have those two arrows coming out, but they didn't draw a circle around it. Sometimes you'll see that. Please note that those little arrows coming out, what are they? They're photons. There's light escaping from that diode. That's what that's actually representing. Now I sort of copied their style when I drew these. A node, a named node. So whatever is in there, whatever is in node name, that would be the name of that. And of course, you could call it anything you want. You'd choose a useful name and call it that. Aha, now I represented two different ways of doing 5V. This thing on the left here, this is like what I used. And I used actually, that's what I drew, hand drew. This piece of software called Fritzing. Fritzing is a project that is open source. You can download the source code, but it is no longer gratis. It's no longer free to purchase because the project was running out of money, and it was originally sponsored by a university, but not anymore. That's my understanding. It seems complicated. In any event, you can no longer download it for free, so I'm not going to ask you to use it. However, Fritzing uses what I think is a more comfortable symbol, this 5V with the underline. This 5V is how you'd represent this in Circuit Lab. That's one way to represent it. Similarly, on the left side there, that's the Fritzing symbol. And on the right, Circuit Lab uses this just downward pointing arrow, and that represents ground for them. That's actually a very common representation as well. And finally, a battery. Please do note just as I've drawn them, the longer and the shorter ends of the battery, the long end is the positive one and the short end is the negative one. So that's enough symbols that we're actually going to be able to use these, put some circuits together, and start to think about electrical flow. And that's what's up next.